Hello everyone. Welcome to another episode of Deep Dive Knowledge Talk. Greetings! I'm curious to understand how attention mechanisms facilitate Transformers' remarkable performance. Can you elaborate on the fundamental concept and its implementation?
The attention mechanism is like a spotlight that helps the Transformer network focus on the most important parts of a sequence of data. It allows the network to understand the relationships between different elements in the sequence and to make better predictions. Imagine you are trying to translate a sentence from English to French. The attention mechanism would help the Transformer network focus on the most important words in the English sentence and then generate the correct French translation. The attention mechanism is implemented using three main components. 1. Query. Query. This is a vector that represents the part of the sequence that the network is currently focused on. 2. Keys. These are vectors that represent each element in the sequence. 3. Values. These are vectors that contain the information that the network is interested in. The query vector is compared to each of the key vectors, and the resulting scores are used to calculate a weight for each value vector. These weights are then used to combine the value vectors into a single output vector, which is the output of the attention mechanism. The multi-head attention mechanism is a variant of the attention mechanism that uses multiple heads to attend to different parts of the sequence. This allows the network to capture more information from the sequence and to make more accurate predictions.
Fascinating. So, the multi-head attention mechanism enables the Transformer to simultaneously attend to diverse aspects of the input sequence, enhancing its residual capacity. How does this mechanism contribute to the overall effectiveness of Transformers in various natural language processing tasks?
Multi-head attention mechanism contributes to the overall effectiveness of Transformers in various NLP tasks by allowing the model to attend to different parts of the input sequence and capture different types of relationships between words. This is achieved by using multiple attention heads, each of which focuses on a different aspect of the input. For example, one head might focus on attending to the syntactic structure of the sentence, while another head might focus on attending to the semantic meaning of the words. By combining the outputs of these different heads, the Transformer is able to get a more comprehensive understanding of the input sequence. In addition, the multi-head attention mechanism allows the Transformer to learn long-range dependencies between words in the sequence. This is important for tasks such as machine translation, where the meaning of a word can depend on words that are far away in the sentence. By using the multi-head attention mechanism, the Transformer is able to capture these long-range dependencies and generate more accurate translations.
Intriguing! By incorporating multi-head attention, Transformers gain the ability to discern diverse facets of the input and capture intricate relationships within the sequence. How does this mechanism contribute to the Transformer's proficiency in tasks like sentiment analysis and question answering, where comprehending the context and relationships between words is crucial?
In natural language processing, understanding the context and relationships between words in a sentence is crucial for tasks such as sentiment analysis and question answering. Multi-head attention mechanisms play a vital role in enhancing the capabilities of Transformers in these tasks. Let's imagine a sentence. The movie was fantastic, but the acting was terrible. A Transformer model using multi-head attention can process this sentence by breaking it down into individual words and representing each word as a vector. Multi-head attention allows the Transformer to attend to different parts of the sentence simultaneously. It uses multiple heads to focus on specific aspects of the sentence. For example, one head might focus on the relationship between movie and fantastic, while another head might focus on the relationship between acting and terrible. By considering multiple perspectives, the Transformer can better understand the overall meaning and context of the sentence. This enables it to perform tasks such as sentiment analysis, where it can determine whether the sentence expresses positive or negative feelings, or question answering, where it can extract relevant information from the sentence to answer a question. Multi-head attention helps transformers capture the complex relationships between words and enhances their ability to understand the context of a sentence, making them powerful tools for various natural language processing tasks.
Fascinating. It appears that multi-head attention empowers transformers with a nuanced understanding of the input by simultaneously attending to diverse aspects. How does this mechanism contribute to the transformer's effectiveness in tasks like machine translation, where preserving the meaning while adapting to a different language is crucial?
The multi-head attention mechanism in transformers plays a vital role in preserving meaning while adapting to different languages in translation tasks. It operates similarly to how we retrieve data from a database. When we search for information in a database, the system identifies the key in the database that most closely matches our query. This key then provides us with the corresponding value, which is the information we seek. The multi-head attention mechanism in transformers follows a similar approach. It compares the input sentence with the target sentence to identify the most relevant words and phrases. This allows the transformer to understand the meaning of the input sentence and generate an appropriate translation in the target language. The multi-head attention mechanism also helps the transformer to maintain the context and relationships between words in the input sentence. By attending to multiple parts of the input sentence simultaneously, the transformer can capture the overall meaning and produce a coherent translation. Overall, the multi-head attention mechanism enables transformers to effectively adapt to different languages in translation tasks by preserving the meaning of the input sentence while generating translations that are fluent and accurate in the target language.
Envisioning the multi-head attention mechanism as a database retrieval process provides a clear analogy. In tasks like abstractive summarization, where the transformer generates a condensed yet informative summary from a given text. How does this mechanism contribute to capturing the key points and maintaining the coherence of the summary?
The multi-head attention mechanism plays a vital role in enabling transformers to capture key points and maintain coherence in abstractive summarization tasks. This mechanism allows the transformer to attend to different parts of the input sequence and generate a summary that is both informative and cohesive. Here's a simplified analogy to understand how multi-head attention works. Imagine you have a group of friends, and you want to summarize a conversation you had with them. Instead of trying to remember everything everyone said at once, you might focus on different parts of the conversation at different times. For example, you might first focus on what your friend A said, then what friend B said, and so on. In a similar way, the multi-head attention mechanism allows the transformer to focus on different parts of the input sequence and generate a summary that captures the most important points. Each head of the attention mechanism attends to a different part of the input, and the outputs from all the heads are combined to create the final summary. This process helps the transformer to identify key points and maintain coherence in the summary. By attending to different parts of the input sequence, the transformer can capture the relationships between different parts of the text and generate a summary that is both informative and cohesive.
That's an interesting analogy. To delve deeper into the technical aspects, how does the multi-head attention mechanism handle the challenge of varying sequence lengths in tasks like question answering, where the length of the input question and context can vary significantly?
The multi-head attention mechanism can address the challenge of variable sequence lengths in tasks like question answering, where the input question and context can vary significantly in length. Here's how it works. Imagine you have a question like, "What is the capital of France?" and a long context document about France. The multi-head attention mechanism allows the model to focus on the relevant parts of the context document that are related to the question. Instead of processing the entire context document sequentially, the multi-head attention mechanism divides the context into smaller chunks, known as heads. Each head attends to a different part of the context, extracting important information. These heads work independently and in parallel, allowing the model to process the context more efficiently. By combining the information from all the heads, the model can better understand the relationship between the question and the context. This approach enables the model to handle variable sequence lengths effectively, as it can adjust the number of heads and the size of the chunks based on the length of the input and context.
Thank you for explaining how the multi-head attention mechanism handles varying sequence lengths. To further explore its capabilities, can you elaborate on how it contributes to the transformer's success in tasks like named entity recognition, where identifying and classifying specific entities in text is crucial?
Multi-head attention is a technique used in transformer networks to allow the model to attend to different parts of the input sequence simultaneously. In the context of named entity recognition, this allows the model to identify and classify different types of entities, such as persons, organizations, and locations, in the text. Each head, the multi-head attention mechanism, attends to a different aspect of the input, and the outputs of the different heads are concatenated to produce the final output. This allows the model to capture a more comprehensive restity of the input sequence, which is essential for accurate named entity recognition.
Excellent. To delve deeper, how does the multi-head attention mechanism facilitate the transformer's ability to handle long sequences, such as in machine translation tasks, where preserving context over extended text is crucial?
The multi-head attention mechanism enables the processing of long sequences in machine translation tasks by allowing the model to focus on different parts of the input sequence and attend to relevant information. Imagine a long sentence as a series of words, like a line of dominoes. Each domino represents a word, and the order of the dominoes matters. The attention mechanism works like a spotlight that can shine on different dominoes at the same time. This allows the model to consider multiple words in the input sequence and understand their relationships, even if they are far apart. By using multiple heads of attention, the model can attend to different aspects of the input sequence simultaneously. For example, one head might focus on the subject of the sentence, while another head focuses on the verb. This helps the model capture complex relationships and dependencies within the sequence. In the context of machine translation, the multi-head attention mechanism enables the model to attend to both the source language sentence and the target language sentence being generated. This allows the model to understand the meaning of the source sentence and generate a fluent and accurate translation in the target language.
Thank you for the explanation. How does the multi-head attention mechanism contribute to the transformer's effectiveness in text classification tasks, where the model needs to categorize a piece of text into one or more predefined categories?
The multi-head attention mechanism plays a crucial role in enhancing the effectiveness of transformers in text classification tasks. Here's how it contributes. 1. Contextual understanding. Transformers use multi-head attention to capture contextual relationships within the text. The mechanism allows the model to attend to different parts of the input sequence simultaneously, considering their relevance to the classification task. 2. Feature extraction. The multi-heads in the attention mechanism extract diverse features from the input. Each head focuses on specific patterns or aspects of the text, providing a comprehensive restity for classification. 3. Positional encoding. Transformers lack inherent knowledge of word order, like recurrent neural networks. The multi-head attention mechanism incorporates positional encoding, which helps the model understand the sequence and order of words in the text. 4. RAR. Query key matching. The attention mechanism uses query and key vectors to calculate the relevance of different parts of the input. This matching process enables the model to identify important words and phrases for classification. 5. Weighted aggregation. After calculating relevance scores, the multi-head attention mechanism combines the outputs from different heads using weighted aggregation. This weighted combination provides a more robust restity for text classification. Overall, the multi-head attention mechanism in transformers allows for a deeper understanding of the context, effective feature extraction, and accurate classification of text.
Thank you for the detailed explanation. How does the multi-head attention mechanism contribute to the transformer's ability to handle tasks like question answering, where it needs to extract specific information from a given context?
The multi-head attention mechanism is a powerful tool that allows transformers to process tasks, such as question answering, where specific information needs to be extracted from a specific context. Imagine you have a big bowl of fruit, and you want to pick out all the apples. You could go through the bowl one piece at a time and check if each piece is an apple. But that would be very slow and inefficient. Instead, you can use a multi-head attention mechanism. This mechanism allows the transformer to look at the entire bowl of fruit at once and identify all the apples in one go. It does this by creating multiple heads that each focus on a different aspect of the fruit. For example, one head might focus on the color of the fruit, while another head might focus on the shape. By combining the information from all of the heads, the transformer can quickly and accurately identify all the apples in the bowl. In the same way, the multi-head attention mechanism allows transformers to extract specific information from a specific context. For example, if you wanted to answer the question, "What is the capital of France?" the transformer can use the multi-head attention mechanism to identify the relevant information in the context, e.g., France is a country in Western Europe. The capital of France is Paris. The multi-head attention mechanism is a key component of transformers, and it plays a vital role in the transformer's ability to process tasks such as question answering.
Thank you all for joining us today for this fascinating discussion. As we wrap up, let's revisit the key takeaways. Attention mechanisms play a pivotal role in the remarkable performance of transformers. The multi-head attention mechanism allows transformers to attend to different parts of the input sequence simultaneously, facilitating the capture of diverse aspects and intricate relationships. This mechanism enables transformers to handle varying sequence lengths effectively and perform well in tasks like machine translation, abstractive summarization, named entity recognition, text classification, and question answering. The multi-head attention mechanism contributes significantly to transformers' effectiveness in various natural language processing tasks. Thank you again for being here. Please join us next time for another engaging technical discussion.